Hello everyone, welcome to this channel, and today in this video we will be discussing the plane in three-dimensional geometry. And in the previous video we have covered the line. So let us start. So we will discuss about the plane today, and the plane is very simple. And it is very quite similar to the line. So here we have to again find out the equation of the plane. So to find out the equation of a plane, first of all we have to understand some concept related to the plane. The direction cosine, or the direction ratio, that is dr, the direction ratio is always a normal line which is perpendicular or normal to the surface of the plane. For example, this is the surface of the plane, and the direction ratio of this will be a line which is normal to the plane. So you will always take it like that the direction ratio of any plane is always normal or always perpendicular to its surface. Okay, so in this plane also we require two things to calculate the equation of a plane, that is point plus direction ratio. So from where we will calculate the direction ratio? Direction ratio may be given or may not be given directly, or indirectly it is given, so we have to find out it. Okay, so in this plane the main questions will be in your syllabus. Maybe for example, like this is a plane, and this plane is passing from a given point, and it may be parallel to some other plane. Then what will happen? These two direction will be parallel to each other. These two direction ratios will be parallel to each other, and we will put the direction of this plane into this plane, and we will calculate the equation of this plane. But what is the equation of a plane? So I'm telling you, you have to understand this. This is a plane which has the direction ratio ABC, and it is passing from a given point. Let us suppose point A, whose coordinates are, I'm taking it, let us suppose P, Q and R. Then the direction, no, not direction, then the equation of this plane will be given by this equation, like x minus p, y minus q, z minus r, and you have to multiply these direction ratios like this. A, this is plus b, this is plus c. Put this equals to 0. So this is our equation of the plane, where a, b and c, these are the direction ratios, and p, q, r, this is the point from where this plane is passing. Okay, now in your syllabus you have several type of equation, like you have to find out the equation of a plane which may be passing from multiple points. For example, 3 points are given. Okay, and you have to find out the angles between these two different planes. You have to find out the distance between a given point and the given plane. How much distance is this? And one more type is there, like you may have to find out the uh, distance from the origin to this plane. This is a special type of question, because wherever you have given the origin, then what you have to do, you have to take the direction cosine whenever the word origin is written. How to calculate direction cosine? For example, you are given I plus 4j plus 2k, and how you will take the direction cosine? You just do the magnitude of this, 4 square, 2 square, and take the under root of this comes out to be 1 plus 16 plus 4, that comes out to be root 21. So divide it by 1 by 21, that is 1 by, not 1 by, it's by 21 only, and 2 by 21. So this becomes the direction ratio, direction cosine. This is direction cosine. For example, you have to find out the now before that I should tell you about the vector equation of a plane. Vector equation of a plane. The vector equation of a plane will be given like r dot n cap equals to d, where d is the distance from the origin and r is a vector which is given. For example, this is a point plane, and r xi plus yj plus zk, this is a normal point vector, this is a simple point vector, and this n is a normal vector to the surface, or a perpendicular vector to the surface of the normal unit vector. Okay, this n cap is a unit normal vector, and this r is a point vector or position vector which is present on that plane. Okay, so you have to remember this. If this n cap, this is a unit vector, if this is a unit vector, then it means it is a direction cosine. If it is a direction cosine, then this distance d, this is automatically the distance from the origin. So you will find, when I will show you the NCERT, 12th NCERT, and from there you will see this type of question where you have to find out the equation or distance from the origin. There you will find this type of question or you will find a very important question, that is the foot of perpendicular. There is a foot of perpendicular from the origin. Wherever you find the word origin, then you have to take the direction cosine. If you are given any ordinary point like ABC or PQR, there you need to calculate the simple steps to calculate the direction ratio, not cosine. Cosine only in terms of direction, the word origin is given, right? So I am showing you the NCERT's question. So there it is, this is a plane. So equation of a plane in a normal form, this is given here. I already told r dot n cap equals to d, where n is a unit normal vector, r may be any vector, which is given by the same which I just told you. This is x, y, z, and this n cap is a unit vector, where l, m, n, this is a direction cosine, and we know that l square plus m square plus n square equals to 1. The square of the direction cosines equals to 1. The sum of the square equals to 1. And in this Cartesian form, this becomes lx plus my plus nz equals to d, because we have taken this l, m, n are the direction cosines. So this l, m, n are the direction cosines, or otherwise it will be the direction ratios in any normal case. So let's see the question number 13. We have to find out the vector equation of a plane which is at a distance of 6 by root 29 from the origin. The word is origin, and we have to find out its normal vector from the origin is this. The origin vector is this, and we have to also find out this Cartesian form. So the unit vector is given by this is already given, and we have to find out a equation of a plane which is at a distance of this. So we know that this should be on the right hand side, 6 by root 29, and the vector which is given, this is given here, just put it over there. Now we know that the word is origin, so just calculate its magnitude. 2 square, that is 4, minus 3 square, that is 9, 4 square, that is 16. So do the square of these and add these and take the under root, which comes out to be root 29. So divide both sides by root 29. So you will get 2 by root 29, 3 by root 29, and 4 by root 29, and this is 6 by root 29. So this gives us the vector equation, that is r dot, this is direction cosine, and this is the perpendicular distance from the origin. So if we are also required to calculate the Cartesian form of this equation. The Cartesian form will be given by simply just write down, this is 2x, this is 3y minus 3y, this is 4z equals to 6 by root 29, or this equals to 6. Just write down x, here y, here z, and put this equation in x, y, z terms. This will give us a Cartesian form. I think this question is clear to you. Next, we have to find out the direction cosine of a unit vector perpendicular to the plane. This equals to 0. So I already told you have to write it like this plus 1 should be on the right hand side, so this become minus, so we should always take it as a positive, so we will take a negative common, and this will give minus 6i plus 3j and plus 2k. Now we will take the under root of this and divide it to the both side. After that this will become our direction cosines. That's it. इसमें बस एक बात याद रखनी है, वेयर एवर यू फाइंड द वर्ड ओरिजिन, तो जो भी साइड है वो साइड हमेशा पहले क्या आएगा, पॉजिटिव टर्म्स आएगी. जो भी यहाँ पे वेक्टर गिवन है उसका मैग्नीट्यूड निकाल के दोनों तरफ भाग करा दो, डिवाइड इट टुवर्ड्स द बोथ साइड बाय दैट वैल्यू. And this coefficient of I, J, K, the coefficient of I, J, K will be your direction cosines, and this distance, this is a perpendicular distance from the origin. Okay. Next we have to find out the distance of the plane from this origin. Origin से this plane की equation distance बतानी है. How we will calculate? We will take this 6 to the right hand side. So again we will do the 2 square plus minus 3 square plus 4 square. This comes out to root 29. So this comes out to be 6 by root 29. This is our direction cosine, and the distance which and then the value which is on the right hand side, this is our perpendicular distance from the origin itself. Now we have to find out the coordinate of the foot of perpendicular drawn from the origin to this plane. The word again is origin. So what we'll do, we will again do the same procedure. This is 2x minus 3y plus 4z equals to 6. This is 6. Now take the square of these values and add them and take the under root. That this is 29. So divide it by root 29, and this gives them this is the equation of the normal or this plane. This is the plane, and we have to find out this coordinate of this value, this point P, which is taken as x1, y1 and z1. This is the perpendicular drawn from the origin, and we have to find out the value of P. Now we have calculated the equation of this plane, which is normal, which is this equation. Now we know that this plane is, this direction ratio is always perpendicular to this plane, and this point OA, OP, this is also a straight line, so we can calculate the direction ratios of this. Since this OP is also an direction, what, direction ratio or direction cosine? It may be direction cosine, it may be direction ratio, both this direction ratio and direction cosine of this plane, because this plane is passing from the this distance is from the origin. We have to find out the OP from the origin. This point is O, that is origin. Wherever the word origin is written, we have taken the direction cosines. So this direction cosine and the direction ratio of this plane both are in the same direction, so they should be in the same proportion. So for that we will calculate the direction ratio and direction cosines proportional values. Will solve like that way. Like the direction ratio will be x1, this is origin, that is 0 0, so this is x1 minus 0 x1, y1 minus 0 y1, z1 minus 0 z1. So this is x1 divided by the direction ratio of direction cosine of this plane, which is 2 by root 29 minus 3 by root 29, 4 by root 29, this, and we will put this value equal to k. So from there we will get a corresponding values of x1, y1, z1 in terms of k. Since these x1, y1, z1, this value is also present on the plane, so we'll put this value in this plane equation. By substituting this value in the equation of plane, we get the value of k equals to this. If we get the value of k, then again substitute back this equation into this equation. From there we will get the value of x1, y1 and z1. Okay, so this is the special case where when the word is given as origin. If this word is word origin is not given in any, you can say any normal point is given, then you don't require to calculate the under root of this direction cosine of this, not under root, this direction cosine. Instead of that, you just directly proceed. Okay, no need of taking this direction cosine, you just take direction ratios. Okay. Next type of question, the equation of a plane perpendicular to a given vector and passing from a given point. Already we have done. this is a plane passing from a given point and it is perpendicular to a given vector. This given vector which is perpendicular to it, it is always a direction ratio. Point we know, direction ratio we know, we can always calculate it. Already told you, like this. A, B, C, these are the direction ratios. X1, Y1, Z1, this is the point from where this plane is passing. Next question, number 17. Find out the vector in the Cartesian and vector both form which passes from this given point and perpendicular to the line whose direction ratios are given by this. Perpendicular to a line, ये plane जो है एक perpendicular है, this is perpendicular to a line whose direction ratios are this 2, 3, -1, and passing from a point this. You can always do this is x minus this, y minus this, z minus this into multiply it by 2, which किसको multiply करेंगे 2 से, 2 into x minus 5 plus 3 into y minus 2 minus 1 into z plus 4 and put it equals to 0 and solve this equation, get your answer like this. 2 into this plus 3 into this plus z into this, solve this is the required answer. Now find out the equation of a plane passing from the three non-collinear point. Collinear point means these are in the same line, but non-collinear they may not be on a same, they should not be on a similar line. They may be forming a triangle. Okay, they may be present at different locations of this plane. So how we will find out? So this is very simple. So for that, what you require to do, for example, 3 points are given, 1 point, 2 point and 3 point. So what will you do? You don't know the direction ratios. Let us suppose these are ABC. So what will you do? Just assume ABC are the direction ratios and this given point 1, this is 1, this is 2, this is 3. So what will you do? So from the point number 1, you will calculate the simple equation of a plane using the point and direction ratio ABC. So after that, this point number 2, this 2 point, second number point, this is also present on the plane. So this plane will also satisfy the equation of the plane, which is formed by using the equation or by using the point number 1. Again, we will put the point number 3 in that equation and we will get the two equations, one from the second and one from the third in terms of ABC. So we have the ABC in two equation and we will solve it. Okay, after solving we get the value of ABC and put the value of ABC back into the main equation which was formed by using the point number 1 and get our answer. Or you may use a direct formula. This is a direct formula which is a determinant formula. Put in this and get your answer directly. But I told you from that lengthy procedure, or you can say very good understanding method. So these are the 3 points you can also calculate. Now, intercept form of a plane. In this intercept form, you will find that there is a plane which have intercept on A on x-axis, B on y-axis, and Z on C on z-axis. Then from there you will get a equation of a plane in the intercept form, that is x by A plus y by B plus z by C equals to 1. It's a simple. We have to find out the equation of a plane with intercept 2, 3, 4 on the x, y, z respectively. So x by 2, y by 3, z by 4 equals to 1, and this gives us the equation of a plane. Now, plane passing through the intersection of the two given planes. This plane 1, this is the plane 1, this is the plane 2. There is another plane which is passing from the intersection of these two planes. So how we will calculate? We will add the plane number 1 plus lambda into plane number 2 and put them equals to 0. So this is the equation of our required plane. So how to calculate this value of lambda? Now you will be given in another statement like this plane is passing from a given point. For example, this point may be 1 to 3 x y z, whatever the point is given. So you will just substitute the value of x, y and z, x, y, z, whatever the value is there, you just substitute, calculate the value of lambda from there and put it back into this equation, get your answer. For example, the point is not given, then what may be given? The question is ना, अब क्वेश्चन ये हो सकता है कि अब यहाँ पे पॉइंट नहीं गिवन है, तो और क्या गिवन हो सकता है? और गिवन ये हो सकता है, दिस प्लेन may be parallel to some other plane. If a plane is parallel to some other plane, then what does it means? This means the direction ratios will be same. So just put the direction, the coefficient of x here, the coefficient of y, the coefficient of z, put these, the coefficient equals to this, and from there calculate the value of lambda. And if not, then this plane, plane 1 plus lambda into plane number 2, this is p2, plane 2, plane 1, so this is the required rp, that is required plane. So in this required plane, if this plane is maybe perpendicular to some other plane, then how we will do? If plane 1, which this is our required plane, this is our required plane, and it is perpendicular to another plane, this is a plane which is perpendicular to this, then its direction ratio will be like this. This is perpendicular to this, so direction ratio will be towards this. So both of these directions are perpendicular, so their dot product will be 0. So just calculate, just multiply and add them and put equals to 0. When we put them equals to 0, from there we will calculate the value of lambda and substitute the lambda value back into this equation and get our answer. This is the equation. This is the first plane, this is the second plane, and this is passing, and the intersection is passing from this point 1 1 1. So how we will do? We will just add these two planes like this, d1 plus lambda d2. This is the d1 first plane, lambda into d2. After that, this is the first plane, this is the second plane, this is the third, this is the first and the second plane. We have added them and we have put it equal to whatever the value is given. Now after that, we just substitute the value, the point that is 1 1 1, we substitute the value like 1 1 1, and from there calculated the value of lambda and put the value of lambda back there, and from there we get the equation of our plane. Now coplanarity of two lines. When will be the two lines in the coplanar? Coplanar means एक ही plane के अंदर line है. When the two lines will be in the coplanar, when their area under that two lines is 0. ठीक है, area under the curve is 0, then they are in the same plane. For example, this is a plane. If lines are present in this, then these are coplanar. If one line is present on this plane and another line is present on another plane, so the area will be there, but on the same plane the area will be 0. So we will use the determinant method, and the formula for that will be x2 minus x1, y2 minus y1, z2 minus z1, a1 b1 c1, a2 b2 c2. So what will we do? This is very simple approach. This is the determinant, this is the second row, this is third row. In the second row, put the direction ratio of this there like -3 1 5, and in the direction ratio of second line in the third row like -1 2 5, and in the first line you will just put the difference between these 2 points. Okay, the point is -3 plus 1 plus 5, here -1 2 and 5. Just take the difference of these and put that difference here and calculate. If this difference this determinant comes out to be 0, then these two lines are coplanar, otherwise these are not coplanar. Now the angle between these two planes, already mentioned, whenever you are required to calculate the angle between two planes, two lines in the two similar things, then you have to take the angle cosine of theta, or cosine of the angle between these two. And the process is again simple. The cos theta will be n1 dot n2 divided by their magnitude, n1 magnitude and n2 magnitude. Now the simple question is there. We have to find out the angles between these two planes. Here the direction ratio will be 2 1 minus 2, here 3 minus 6 and minus 2. Again, just do the simple dot product and divide it by their individual magnitude, and from there you get the value of angle or theta. Again same question, and then the next type of question, distance of a point from a given plane. So you may be given a point, that is, let us suppose this is PQR. From this point you need to find out the distance of a given plane, which is given in this form, in like ax plus by plus cz plus equals to d. Then how you will proceed? This is the formula. This is the plane with ax plus by plus cz minus d equals to 0. What happened? Pen stopped working. So there you see, this is ax plus by plus cz equals to, this is the given plane, and it is passing from a given point x1, y1 and z1. So what will you do? Just put ax plus by plus cz minus d, that is the simple plane. Why I have replaced this x, y, z? I have replaced this with this x1, y1 and z1. This is the given point. So just substitute the value of given point into this equation and divide it by the square of this coefficient of x, y, z, that is a square plus b square plus c square, and take the under root of that and do the magnitude and calculate it. They are simple. So angle between a line and plane, already told you, when you have to calculate the angle between the same things, you will take the cosine of theta. If you are required to calculate the angle between the two different things like plane and line, so how will you do? So you know the direction ratio of line and direction ratio of line and direction ratio of plane. You already know how to get the direction ratio and where the direction ratio of line and where is the direction ratio of a plane. So just put them into the simple formula, and the sine of theta will be the angle between these two. Now we are doing their question. In each of the following, we have to determine the direction cosine of the normal to the plane from the origin of this. So what will be the answer here? This, I am taking this example, 2x plus 3y minus z equals to 5. How will you do? You just take the square of this, 2 square plus 3 square plus 1 square minus 1 square, 1, 4 plus 9 plus 1, that is root 14, divided with root 14 to the both side. So direction cosine will be 2 by root 14, 3 by root 14 minus 1 by root 14, and the distance from the origin will be 5 by root 14. That's simple. Next question, we have to find out a vector equation which is at a distance of 7 unit from the origin. The word is origin. So what will you do? Put this equals to 7, take the magnitude of this, divided with this comes out to be 36 plus 25 plus 9. This comes out to be how much? This is 51 or 61, 6 और 5 11 और 9 20, root 70. So root 70 by root 70. So the vector equation of a plane, this is the vector equation. 3 by root 70, 5 by root 70 minus 6 by root 70, ijk, put the ijk corresponding there, and you put them equals to root by 70, 7 by root 70. So this will be at a root distance of 7 unit from the origin, right? Next question, we have to find out the equation of a plane passing from this plane. Again very simple, Cartesian. This becomes x plus y minus z equals to 2. Just replace ijk by xyj. Put a perpendicular from the origin, already told you in example. You have to find out a vector equation passing from a point parallel to the and normal to the plane. So this is the direction ratio, this is the plane, this is the point. It is very simple question to do. Next, point is given, normal vector, you will do it. From passing from 3 points, you will get the equation in ABC, 2 equations, and solve them. Next, find the intercept from intercept cut by this plane. Intercept बताने हमें, this will be divided both sides by 5, so it becomes what, 5 by 2 plus y 5 plus z by minus 1 equals to 1. So x intercept comes out to be this y intercept, and this is z intercept, and this will be our answer. Next, find the equation of a plane which is intersection of these two planes and passing from this point. Very simple question to do. Again, simple point is given, and again next is perpendicular to this. So what will you do when you will calculate the required plane? By adding lambda into this is the required plane, and we will put the direction cosines dot product equals to 0, because this is perpendicular to this plane. The direction ratio will be 1 minus 1 and plus 1. So do the just simple dot, take the dot product and put that equals to 0. From there calculate the value of lambda. Next, find the angle between these two planes. Very simple, you have to find out the angles between these two planes. You know the direction ratios. Okay, you know the direction ratio of all these things. Very simple, you have to calculate the cosine of theta. Cosine of theta equals to direction ratio of this dot direction ratio of this, means dot product of the direction ratio of this and individual magnitude of this and individual magnitude of this equation. Next and the last question of the day, we have to find out the distance from the given point to this plane. So what will you do? Just substitute this point and divide it by the magnitude of this. Get your answer. So that's all for this video, and thank you very much for watching it.